What's poppin', dogs? Mr. Allen here with some expanding and condensing of logarithms in this video. I've got two examples of each, and if you're in your logs unit right now, one of each of these is definitely popping up on your test. So for the first one, I got to write each as a sum or difference of logarithms. That's expand it. And then oftentimes it'll say evaluate if possible. We'll talk about that in a moment. So for this first one, I got log base 4 of x squared divided by y times z cubed. We're going to expand it, basically make it look like these guys. So I'm going to have a bunch of log base 4s. I got 3 of them that I'm going to have, okay? So I'm going to have log base 4 of x squared, and then division. What does division expand to? Well, division expands to subtraction, whereas multiplication expands to addition, okay? So each one. So I'm going to subtract log base 4 of y, but question here, it's y times z cubed. So is it going to be addition or will it be subtraction? Well, since I'm dividing by that z cubed, like imagine if this y wasn't here, I'd still be subtracting log base 4 of z cubed. So minus log base 4 of z cubed. That is a tricky one that gets a lot of people. So pay close attention to that, because if I'm dividing by that stuff, you're going to have negatives. It's kind of like with exponents. My exponent is negative when it's like in the denominator. If I brought it back up to the numerator, it would be a negative exponent. I make that connection because logs, exponents, they go together like peas and carrots, okay? Forrest Gump reference. All right, let's finish this thing up, because the other thing they're going to want you to do is bring those exponents, like this 2 here, out as a coefficient, this 3 out as a coefficient, okay? So that's our next step here, and that'll be your final answer. So we're going to have 2 log base 4 of x minus log base 4 of y minus 3 log base 4 of z. That is my fully expanded form here. Cool? It's dope. It's awesome. One thing to point out with logs, make sure that 2 log x, log y, 3 log z, those are all in the same line of font. The 4s are all subscripts. They're lower and smaller. So don't get lazy with that, because I see a lot of people, they'll write the 4 in line and the x all of a sudden becomes an exponent. No, 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 no. Not good. No bueno, if you will. No bueno. Okay? So make sure, keep that in line. Cool. Let's see here. We'll go blue for this next one. Let's see. Log base 2 of at 8 times x to the 6th divided by y times z both to the 3rd. Interesting. Okay. So let's expand this thing. And what do you think is going to happen here? That'll be y to the 3rd, terrible 3, z to the 3rd, right? That's what's happening in this denominator. I'm not going to rewrite the whole thing. That's a lot to rewrite. But let's remember that the exponent would distribute across multiplication, okay? So I have log base 2 of 8 plus, because it's multiplication, they're both in the numerator. I more so associate it with like it's in the numerator when I'm dealing with a fraction. Anything in the numerator is plus. Anything in the denominator is minus. We're subtracting because we're dividing by it, okay? I know it seems weird. We're subtracting because we're dividing. It's a log property, right? If you need help with the log properties, I've got a video on all the log properties and other practice, so be sure to watch it. If you're like, bro, I don't know what you're talking about, pop back to that log property video right now. I will try my best to remember to link it somewhere in here for you guys. Because that'll be super duper helpful. All right. Then I got x to the 6th here. And then let's see here, minus, because we're dividing, minus log base 2 of y to the 3rd. And then minus log base 2 of z to the 3rd. Okay. So there we go. 4 things here. Now, what's next? I'm about to put my marker away like I'm done. I'm not done. Log base 2 of 8. This is where I was talking about you can evaluate if possible. Okay. I will save that. Actually, we'll do that right now. 2 to what power gives me 8? That's how you evaluate a logarithm in your brain scheme, okay? 2 to what power gives me 8? 2 to the 3rd gives me 8. So that's going to become 3 plus, and now we'll just bring that exponent down as a coefficient, minus, and then we got exponent coming down as a coefficient, whoop, y, and then minus exponent coming down as a coefficient. I've said that 3 times now. Yay! That's it. Log base 2 of 8 is 3. 6 comes down as a coefficient. 3 comes down as a coefficient. 3 comes down as a coefficient. We're good to go. Everything is log base 2 otherwise. My marker is running out. Boom. Love it. Nice. We have expanded, written as a sum or difference of logs. Now it's time to condense and write it as a single logarithm. You might be wondering, like, what's the point of this, bro? Oftentimes we do some condensing in solving logs, and it's also just like good practice being able to take it apart, put it back together. It's good brain work, honestly. Okay, it's good to take things apart, put them back together, in as an exercise of the brain, like a Sudoku puzzle, but math, and awesome. All right. 2, natural log. Ooh, log base E action. Natural log of x minus 6 natural log of y to the 1/3 plus 2/3. Man, I'm really throwing some fractions here. 2/3 natural log of z to the 12th. So what do? Well, everything is natural log. Okay, so everything can go into one natural log. I will break this down into a couple steps. However, I often favor jumping almost pretty much right to the final answer with these, just because there is a lot of writing. Like I often from here, I just jump right to here, or from here right to here, if possible. This one you kind of want to do a little bit on the side, but you're going to start to get the groove here and know that what steps you can skip, okay? For now, since I'm showing you for the first time, I assume, I'm going to show you guys everything. That coefficient can go up as an exponent, just like the exponent came down as a coefficient, right? These things work backwards. Ooh, over here. If I bring this 6 up, what does it do with that exponent? Well, you could think of this as like a little 1 right here, x to the first. So I did 2 times 1. Same thing goes here. It's like a power to a power, a little side math here. I'm essentially doing, we have, let's see here, y to the 1/3 raised to the 6th. Power to a power, exponent properties, says we multiply, so that becomes 2. So now I have minus natural log of y squared. Over here, let's write down the 2/3, right? So we got 2/3 times 12. 12 times 2/3. You could think of that as 12 divided by 3, that's 4, times 2 is 8. So natural log z to the 8th. Okay, that's looking a little bit more manageable. You might need to do a little bit of side math there, guys. You can also think of this as 12 times 2 is 24, divided by 3 is also 8. So now let's get this into a single log, natural log. And because I have subtraction here, I'm going to need some division. So I'm going to open up a set of parentheses. Let's get a little fraction going here. We have x squared. This is also positive, z to the 8th. So I'll have x squared and then z to the 8th over, the only one in the denominator is my y squared. There we go. Sorry, that 2 kind of blends in with the y there. Hopefully you can tell. So natural log, x squared in the numerator, z to the 8th in the numerator, y squared in the denominator. You might be like, but it's subtraction, and then we have that. That's okay. That's totally okay. This is positive, goes in the numerator. This is negative, goes in the denominator. I could have rewritten these, swapped spots, and you would have thought nothing of it. Okay, so be careful with that. Now, if there were parentheses here with the negative, here and here, then both of these would go to the denominator, because that negative would distribute across, making them both negative. Okay, so different scenarios, different problems. I can only show you so much in one video, which is getting quite long. Thank you for sticking around. If you're still here, love you. Love you. Last one here. We got 8 log. Where's the base? It's base 10. If there's no base written, it's implied that it's base 10. 8 log base 10 of the square root of x plus 3 log of y minus 6 log of z squared. What do? What is going on here? Mathematical side note. Square root of x is the same as x to the 1/2. Okay, so you can rewrite it with a rational exponent, rational being fraction. So if that's the case, wouldn't this be log of 8 times 1/2 is 4? Yes, yes it would. So I rewrote the square root as x to the 1/2, 8 times 1/2 because we're doing power to a power. Essentially what you're doing here is raising this to the 8th, raising this to the 8th, that is x to the 4th. Okay, so that's what we got going on there. Next one, pretty straightforward. We're bringing that coefficient up, so it's log of y to the 3rd minus, and then that 6 and the 2 get multiplied to become 12. So log of z to the 12th. Now, everything's the same log. Everything's in the log, right? We got to get it all in the log. If I didn't state that enough, we got to get it in the log first, and then we can condense it. We did that here, got everything into the log. Now we can condense into one log, and I will need a fraction once again, fraction action, because I got a negative. These first two are positive, so we have x to the 4th, y to the 3rd. That y keeps on getting in my way, man. And then I got z to the 12th. There we go. I planned for it on that one. Nice. That is my final answer. I don't know why I didn't even circle this. Circle. And circle. All right, there we go, guys. Expanding and condensing logs, you're going to see one of each of those on your logs test, guaranteed. And if it's split into calc, non-calc, these are definitely popping up on the non-calc test. So be ready for that. Thanks for watching. If you guys have any questions, pop them in the comments. Otherwise, thank you so much for staying tuned this entire time. You're dope. Stay awesome.